Hello, welcome to our session. This Engineer Jess Mendoza from Electrical Engineering Department faculty. So this time, let's discuss all about uh, the online simulation for circuits 1 that is known as Elementary Electrical Engineering Laboratory. So, on our experience based on actual, so we must need to demo this circuit by using the ohmmeter, and then the module, and then the resistors, and then the connecting wires. So that is based on the actual session. But for the meantime, because we're on pandemic, we have here a simulation that is equivalent to actual. And then this software is known as Multisim software. So this is a software intended for DC or AC electricity. But this time, we're just using the free account. So, but we can access this software, but it have limit. Okay, so this is now the interaction or interactive software. Okay, we have the schematic, and then the grapher, and then we have the split. Okay, and then can we label this one my circuit? So one. Okay. And then, before we start, we must need to familiarize the button on this left side. This one, this is for if you need to find the voltage, okay. And then this is for ammeter, okay. And then this is for dual source, dual quantity, that is it's either voltage or current. This one is for voltage reference. Okay, this one is if you need to have a text or edit, and then this one is digital. This one is for grounding. This is ground, the connector. This is the junction. This is one is the for sources. AC voltage, AC current, clock voltage, clock current. But again, circuits lab 1 is more on DC electricity, so we must need this source as DC voltage source, that is DCC, then is DC current, okay, step voltage, and then step current. Okay, for this lower portion, that is 3-phase delta, 3-phase Y, so that is used for AC electricity. Okay, this one is for resistors. This one, the capacitor, okay, and then the inductor, potentiometer. This is fuse, the transformer, the coupled inductors, and then the resistors. Okay, so for this one, it's analog. This is for amplifier, the 3-terminal op amps, and then 5-terminal ideal, then 5x5 timer, then op amps. Okay. This one, that is for diodes, thinner diode, LED, general purpose diodes. Okay, so there are many tabs or button. Okay, so on for this one, we have this. We have indicators, we have LED lamps, LED bar, and then buzzer. Okay, and then again, this one is for transistors. So we have many configuration, NPN, NPN40, we have PNP, PNP40, NMOS, okay, PMOS, JFET, junction field effect transistor, plus PET, PNPN, and PE, NMOS. Okay. And then here there is switch, single pole, single through, SPST, SPDT, single pole, double through, okay. Time delay switch, control, current control, SPST, okay. Then we have here the molding building blocks. Can be used to the other applications, but for our subject this time, so we just need about or focus on DC electricity. Okay, this one is for electromechanical. It's for relay, normal of open relay, normally closed, combination relay, so minimum. This one is for power, the linear regulators. This one is for digital, END or NEND nor XOR, okay. That is for logic circuits and switching theory. So, okay, let's focus first on our simulation DC circuits one. So, for now, let's just create a simple circuit and then that contains one source or two or more source, resistors, and then or connected series parallel or series circuit or combination of parallel. And then after that, we need to measure those quantities. What are the current absorbed? What are the voltage absorbed? And then by individual resistors. Okay. Again, this one is for the voltage. This is DC voltage. And then we have here these the resistors. This one. Okay. This one. If you need to copy paste, just click this copy button, and then okay, so that's all. Or we can add other resistors. Okay, if you need to flip this circuit, just click this one, okay, and then drag. And then to connect the circuit, you just click this top positive side of V1 to the positive side of R1, leaving up the negative side of R1 to the positive side of R2, and then this one, the negative side of V1 to the negative side of R2. Okay. Okay, for sure, this is series circuit. Okay, if you need to drag the wire, so just click this one and then drag down. And then to complete the circuit, put the grounding terminal at the bottom, any portion at the bottom, either on the left side or on the right side. Okay, after that, if you wish to have the quantity, please just edit this supply voltage. If you wish to edit, just click this 5 volts and then replace this 5 volts to what quantity you are going to use to see 24 volts. Then this R1 will be, let me see, 50 ohms. And then this R2, let me say, this is 100 ohms. Okay? So the question is, what is the current? What is the current flowing through this R1 and R2? So to measure that, we we need to use this ammeter. Okay, the ammeter is just the left portion. Just click this button and then use this current. Okay, ammeter. Okay, because this is a series circuit, so the current flowing through this circuit is the same. Okay, this is now your value of ammeter. And then if we need to have or to look for the value, we just need to simulate. Okay, the simulator loading, which means that our circuit is now simulated. Okay, so this at the upper portion, this is the time delay expressed in milliseconds. Did you notice as the time increases, the value of this ammeter, the reading measured at this ammeter is the same. It's just 160 milliamperes or 0.16 ampere. So this is now the current reads or the current flow through this circuit. If we need to get the value of voltage, we need to use the voltmeter. Okay, the voltmeter is from the left button. Just click this one. Okay, this is the voltage, and then again just get the reference for this one. Okay, so this is the voltage reading of this R1. Okay, to solve for the value of the R2, just place this voltage and then get the reference of the grounding portion. Okay, and then simulate. Okay, so did you notice that this voltmeter reads 8 volts for R1, and then this voltmeter R2 reads 16 volts. If we add this to 18 plus 16 is 24 volts. Okay, so again, as the time increases, the value of the voltmeter is the same because we're on online simulation. But if we need or if we execute this on Max 1, for sure that this reading 8 volts and 16 volts have its tolerance, or the reading is just 7.99 or 8.01. Okay, then this one that is 16.2 or 15.8. So there is there is a tolerance around 1 or 5%. So next is we need to simulate the parallel circuit. To simulate for parallel circuit, again we need this to supply this one, the DC volts, and then we need to have these two resistors. Okay, so if you need to this resistor is in vertical, just click this rotate. Okay, and then just copy this one to duplicate. Or we can have again, or we can use a series parallel circuit. We need to add another resistor here. To complete the circuit, we need to connect this positive side of P1 to positive side of R3. This one, this negative side of R3 to the positive of R2. And then this one, R1, just connect at the middle of R3 and R2. So on for the bottom, the negative side of P1 connect to the negative side of R2, and then if you need to drag or extend this circuit, just click at the bottom and then drag down. Okay, then this R1, click at the negative side of R1 at the bottom, and then after that, place on grounding symbol either of the portion of left side or right side. Okay, and then if you wish to edit these values, just click this V1. If you wish to have, let me say this is 25 volts for R8, R3, that will be to see 300 ohms. This R1, let's say this is 150 ohms. This R2, let me say this is 100 ohms. Okay, to simulate this, we need to have this one. Okay, this is for ammeter reading. Okay, this one, and then this is for the current flowing to this R1. Okay, and then this is the current flowing to this R2. Okay, and then if we have, okay, if we need to measure the value of the leaving current, we can measure this again. We can release this one, and then okay, the polarity is reversed, so we need to flip this one. Okay, the flip is this. Just click this, and then the direction of the arrow is flip. After that, we can have, or we can now simulate the circuit. Okay. Okay, so if you notice, we have a reading. Okay, as the current, as the time increases, so the values of the ammeter stays the same. Okay, that's the reading for R1. We have 27.7 milliamps. For R2, we have 41.67 milliamps. Then for the R3, that is 69.4 milliamps. Then this PR4, that is 69.4 milliamps. Okay, so next is, how about the value of the voltage? Did you notice that the entering current at 69.4 milliamps is the same as this leaving current at 69.4 milliamps? Okay, to be sure for the value of the voltage, if you want to or if you wish to get the reading as soon as possible, or two reading at a time. Okay, this one, just click this. Okay, just place this B over A, so, or have a dual measurement, the voltage or the ammeter or the current, and then this one, just click again together this one, and then so on for this leaving current. Okay, and then after that, simulate again. Okay, so did you notice that the value of V1 is 4.16 volts? Okay, and then this one is 0 volts. Okay, so the voltage for R1 and R2, so we need to correct this one. We need to have the we need to have the grounding reference. Okay, again, this one is for voltage reference. Okay, and then at the ground portion. Okay, so for this one, let's copy this, and then reference portion of the bottom. And then after that, let's simulate it again. Okay, so if you notice, as since this R2 and R1 are connected and parallel, thus the reading is the same as 4.16 volts. Okay, if we need to correct again this for R3, okay, this is the voltage, and then the voltmeter, and then this is the reference point or ground, and then let's simulate this one. Okay, so it is very clear that the value for R3, the voltage is 20.83 volts. Then for R1 and R2, the same reading for 4.16 volts. Okay, at the at the lower portion, the voltage is 0 because it touches at the ground, reference point or the ground. Okay, so this is the online simulation of series on parallel circuit. Okay, if we need to see this on a grapher or a split, let's try this one. This is for the grapher, and then this is for split. Okay, so as you observe that the graph is just a straight line because it is on the DC electricity. Okay, so all for our session. So hope you understand our online simulation for circuits 1. Again, this is just a basic simulation if you need to familiarize with the DC circuits. Okay, thank you.